will be virtual or recorded. So in case you guys want to leave early, I will stick around depending on if I don't get somebody's Scantron, then I will get in touch with them. So that's basically the situation. So I probably will be around for a little bit because I have other work that I have to do. The difficulty with the recordings per se, I have one I have to, it is I still don't have my computer back. It's apparently in computer hospital. It's in computer intensive care. Over because the help desk called me this morning. I'm like, where is my computer? And so apparently it was a significant problem. They finally got it to start, and I was hoping they could just download all my files, the ones I hadn't backed up, and get it to me, but apparently not. They've run into a number, so I don't think I'm going to see it until after the break. Yeah, but they'll call me. But they're not here like all of us are not here a lot during the break. I'm around here enough that it's not that terrible. I mean, it's not like it's tremendously out of the way to be here. But nevertheless, that's the story. So I might even record the lab earlier as I wait for anybody to finish. So the Scantrons are here. I'll have them outside of my office, which is over in the other side, if you're not familiar, over on that other side of John Jay, in that big atrium area, a lot of people hang out. I'm over as you enter toward the far right-hand corner, not quite the corner that's there. Just look for the Spaceballs, the movie, the poster. Spaceballs, the movie, the poster. Help me. I'm a stranger in a strange land. I digress. All right, and we're gonna finish up digestive. Not a lot left to do, digestively speaking, and then we're gonna move on to urinary, which is a busy chapter. So all we have really left to accomplish, and what I was going to do in lab, but we'll save it for. My inclination is maybe because you're at the end of AP2 to see if we can do a mammalian dissection, which would be like a fetal pig or something like that, which might be interesting just to sort of see the lay of the land. Even though it's certainly not identical to us, but it's interesting. So I have an interesting part of lab before we conclude lab the following Thursday prior to finals. And unfortunately, again, your final is Monday. Sorry. So I'll try to give you a heads up. And if I don't, if somebody's thinking about it, remind me to send you a study guide, please. But hopefully I'll remember it. And I anticipate I have that somewhere in my files anyway. So that's all good. Very good. So leave early, be careful, happy turkey stuff. It's all right. Football. So I'll be prepared to be yelled at a lot by the boss. Still watching another game. Yeah. So you recall we went through all of these things that were there, more or less, the segmentation, motor complexes, kind of got through here. Large intestine we did. And really what's left is mostly the physiological aspect that's there. Again, let's see, nothing really significant there. Interesting stuff. Okay, as an aside, we underestimate, and we don't now quite as much because a lot of things we're very probiotic oriented these days. A lot of foods have that. It's very useful digestively. My wife is very into nutrition and supplements and natural remedies. So, I mean, these are the kinds of things that we try to be. She would. I can't bring this in the house because of the chemical. It means a chemical feast. Now, I'm a Fresca addict. You know what? My son came over to stay for a couple of days. We had some. I got hooked again, so I have to keep it here. Like diet beverages, the chemicals they put in, they've always been, for years, we've had a lot of problems with carcinogenic saccharin and cyclamates and other stuff. There's a lot that goes on with it, but nevertheless, so they're extraordinarily numerous. When we get to micro, many of you, I'll point this out again, but they are the good guys. We effectively, they're there for fermentation. I mean, yeah, there's a certain amount of acidity and gas. They play a role with vitamins, particularly B complex and some vitamin K, because vitamin K is important for clotting. And the good guys keep the bad guys in check. The classic example is when somebody gets, and it's a term that you'll be familiar with if you work anywhere in healthcare, called C. diff, Clostridium difficile. And that's normally in your gut, but when we take strong antibiotics, it overwhelms the good guys and the bad guys flourish. We talk about that early on in micro. So fortunately, we are immunologically there. They compete with one another. So there's a whole lot that goes on there that's very protective. So they've looked a lot with health and diseases and manipulating this stuff. This is the antibiotic associated diarrhea. Very significant. C. diff is certainly the big player. It's not the only player with regard to this. Understand, anytime you overwhelm defenses, you sort of lead yourself open to attack. Okay, and this is years ago we used to call this pseudomembranous colitis before we really understood it. Bad news. Bad news. Okay, and all those things are potentially possible. The whole fecal transplant thing is something that bothers me, but I digress with regard to that. It's interesting. I think this is a misstatement. There's a particularly good antibiotic that we'll talk about in micro with many of you. That's called metronidazole, also known as Flagyl. It is brilliant because this is an anaerobic bacteria. They're inherently harder to treat, but it's an excellent medication. I mean, just anecdotally, my kids, when they were very little, and we're talking about like, it was 1986. So they were like 3, 2, and maybe 6 months, and all got super sick because the lady who was my office manager for 15 years, who didn't have any kids at the time, was watching them while my first wife and I were away at a conference. And they lived out in a farm. And apparently, wherever they were, was some contaminated well water. Well, you can imagine all the problems. They all ended up on that same Flagyl. I mean, thankfully, it was comparatively minor, just inconvenient. Okay, what's left stays in the intestine a long time. We really don't see anything more that you could commonly call digestion, other than some finalizations, vitamins, balancing out the water, maybe a few water and electrolytes being reclaimed. And basically, again, its major function is just to get rid of what's there. The reality is, again, we don't need it. Okay, it's non-essential for life. And so, and this is what, even, this is I don't know anymore, having not been hospital-based and done hospital operations for more than 20 years, just how frequently they do ostomy type procedures where you have to either permanently or temporarily have somebody so you can basically attach a bag for that. It's usually in cancer surgery. There's been a lot of problems associated with it. Probably a little more common back in the old days. So it's fairly modal, sequentially contracting, reflexes, mass movements or bowel movements are part of what goes on here normally. And it depends, and most of us are fairly, quote, regular timing and et cetera like this. Interesting things. Okay, this is where, and this is much more of a problem with people older. It's called diverticuli. A diverticulum is a generic term, and I'll tell you about it when we get to the bladder, is a generic term that involves an outpouching, like a bubble in a tire. It's most commonly found in the back. Remember, you have smooth muscle surrounding this. And what happens is like a little gap in the smooth muscle, and it's almost like a little bit of the bowel pouches through it, but it's a fairly weak wall that's holding it in. It's not being held in strong muscles. Muscles are a pretty strong barrier. And so it happens typically, and this is something when you have older folks, they're every X amount of time they're recommended to do colonoscopies to look for polyps, diverticuli, bowel, all those Cologuard commercials, those Cologuard commercials we're inundated with, and all that. That's where that all comes from. So a lot of people my age and older get this, and stuff can get trapped in there. They can burst. There's all sorts of problems with diverticulitis. So it's really significant. I mean, and if it bursts, now you're getting fecal material in the abdominal pelvic cavity. It's just like having a ruptured appendix. Bad news. Irritable bowel syndromes is sort of a common term that we use. You have to address the causes of it more so than anything else. A lot of time that's a default diagnosis until they find out what it is. My kids, when they were little, had two of them had quote unquote irritable bowel syndrome. I can't say that they have had significant problems, some, but it's not the type of thing that you can manage with diet, not so much with medication or anything like that. Mass movements, what they are. Nothing really special to say about that I really care to cover. It's all of when you talk about diarrhea versus constipation. When you're younger, it's more often diarrhea. When you're older, things slow down. It's more often constipation. The longer things stay in there, the more water is absorbed, harder to pass. Okay, so that's if you work a lot with older folks, and this is more apropos for the nursing. This is some of the things you deal with all the time. Okay, so results from the large intestine, it passes through too quickly. Any number of things can have it. Okay, and the big problem with any of these is you're losing in remarkable amounts of fluid, so it alters fluid and electrolyte balance. And then this is, on the other hand, this is the other aspect of it. And it's really, these are much more what we call management problems than anything else, to be very honest with you. So if you know somebody who has these, I don't make light of it. I remember I mentioned that little anecdote about a gal that I went out in high school, and she ended up having to remove her entire colon. She was diagnosed with a terrible immunological disease called ulcerative colitis. This is how it presented when she was in high school. She always had bowel-related problems. He didn't understand it until after, and it was awful because she had a terrible marriage and terrible relationships. Her own family were awful to her. It's just, how can we treat each other so badly? I'll never know. Remember the two most important words: be kind. Okay. I know it's not easy to do all the time, but that's my little saga for today. Okay. So digestion, mechanical absorption. So the whole idea, the bottom line is you got to get to the smallest possible building block to bring them in. So only molecules small enough to get through can be absorbed. Proteins, no, too big. Complex carbohydrates, too big. Nucleic acids, too big. Can't do it. So you got to get them down into, and you might remember from AP1, if you talked a little about monomers and dimers and polymers and things like that. All of those are done with water and enzymes. That's what hydrolysis is. And so basically, we've got to make sure they get through those lining cells. So they pass through the outer area. Remember, that's the apical portion. And eventually through the base layer on the blood side. This is on the lumen, or the opening into the bowel. Typically, even though fatty substances get through pretty easily, most times active transport. So there's a lot of blood supply, and it requires a lot of energy to do that. Okay. So, and as you can see, in the first roughly 2/3 of the intestine, small intestine, most everything's absorbed already, long before it gets down to the ileum, where it's sort of finalizing it. That's the longest part, but the last part. Okay. So all of those things. So there's a couple ways it can get through. It can get through completely, okay, without having to be processed, or it can undergo some degree of processing. It's about the extent of it. So this is the important part, only monosaccharides. Starch, salivary amylase, and then everything else happens in the small intestine. Remember, starches and sugars are broken down to their components. Okay. And so and again, this is the nugget about lactose intolerance. You're missing the enzyme to break it down into those monosaccharides. The beauty of monosaccharides, like glucose, fructose, and galactose, is, I'm fond of saying, all roads lead to glucose. Basically, we can flip those biologically into glucose, or flip them back to something else pretty easily. And they go through all this. And it's about, there's not a whole lot, you don't have to go crazy over this or anything like that. all the different things that are there. Yeah, the pancreatic amylases play a role. The brush border enzymes, that's where the lactase is, sucrase is, maltase is. Again, breaking it down to those individual components so it can pass. And that's really all you have to know about that. I mean, and that's the reason we lack the enzyme for cellulose. Okay, so when we're talking about, so that's why we get dietary fiber. And you have different kinds of dietary fiber. You get soluble fiber and insoluble fiber. The soluble fiber is a little bit easier and it has a great habit of picking up materials like cholesterol and toxic things, potentially toxic things that it can sort of carry along. The fancy name for that is adsorption. It's like it's moving and it'll pick up a rider, okay, as opposed to non-soluble fiber, which we use a lot to treat people with digestive problems, bulk agents and things like that, the metamucils and that kind of stuff. And if you're in the business of treating people, you hear a lot about that. And you hear a lot about it from older relatives. So it's kind of useful. And they go through the whole thing about passing through and active transport and blah, and we don't have to go through all that stuff. So here's the lactose. They're deficient. It doesn't mean it's empty. Babies aren't born with it. People they develop it sometimes over time. Most people know some, and sometimes later in life, it'll disappear again. So like I said, I have a couple of stepkids who basically discovered that they were, I mean, we've been together for roughly 20 years. When we first met, they didn't have a whole lot of digestive issues, a whole lot of limitations. I wasn't surrounded by people who were lactose intolerant and gluten free and blah, 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 and all that. And now it's wild. Like they get any type of dairy product, they're just sick. Okay, just saying. Proteins. Again, it's not only dietary because we do break down a lot of cellular components, but the whole idea has got to be amino acids that are there. And it starts really in the stomach with pepsin and the acidity. Okay. And we go through a lot of things. And we'll see it from pancreatic enzymes and brush border enzymes. But the bottom line is, and without going crazy with the names, just generically know when you hear trypsin, chymotrypsin, carboxypeptidase, anything like that. Okay. Pepsin or pepsinogen, any of those names, they are all protein digesters. And there's not a lot to say. It's not a whole lot different than what happens with carbohydrates. Fats are different because fats are inherently individual units. So we just have to find a way to get them to move. And that's where this concept of emulsification comes down. That's where the bile comes down. And so eventually we'll be able to break things like triglycerides into monoglycerides and free fatty acids. And they get coated with these agents. Lecithin is a very famous agent for this. Pardon the cooking examples. So when you're making something, like if you want to you can make creamy salad dressing, doesn't have to have dairy. Okay. The way I can make it dairy free is we use wet mustard and dry mustard because mustard has less lecithin. When you make a vinaigrette, typically you have oil and vinegar, which you can suspend by shaking. But if you add a little bit of mustard to it, garlic, thyme, salt, pepper, happy dance. Sherry vinegar, if you like, if you're on the Spanish side of things. That bad boy, when you shake it up, okay, mayonnaise, okay, which is effectively the heart of most creamy dressings, uses eggs. There's lecithin in egg yolks. You can do it egg-free. So I make Caesar salad dressing without anything dairy in it, or I can make it egg-free just as easily. Just saying. Happy to give you the recipe. Don't like Caesar salad? Oh, happy to. We don't see it as much now. When you used to go to a fancy restaurant, they would make everything table side. They do a lot. I mean, it really was very high end. Ciro's, 53rd Street in New York. Oh, the good old days. I don't think he's been there for 50 years. What a restaurant. Oh, try it. Okay, and so these are types of things when we study it, these are the way, it's a special way that they're carried, okay? How they can, basically they're carried through the, digestively by these things, micelles. They are able to, then they break apart, okay? And then what happens, back to triglycerides and packaged in things called chylomicrons, and they're the ones that enter the lacteal. It's a lot harder for fats, and that's what's one of the problems is with excessively fatty diets, that transport problems begin to abound. And inevitably you end up with an abundance of particles either in tissues or the bloodstream, and they can be big problems. Okay. Eventually it takes a while until they can, you have to get a big blood vessel like the vena cava for them to enter. So the fat digestion is the most complicated. Here you can see them coating it that are there. And then you can see these little micelles being formed that are there. And they're the ones that can enter. And you'll notice once they break apart, they enter into that lacteal. So it's very much different. It's almost like fat's just a giant globule, and the bile salts break off tiny little droplets and surround it. That's kind of what happens. And the same thing what happens. Anyway, if you want to have some fun and watch the science behind that, it'll always be available on Cinemax. There's a great show from the Food Network that was started around 2000, which must be called Good Eats, with a guy named Alton Brown, who's very, very clever. And he does a lot of the science of cooking. So you can get an idea. They have some really good illustrations of that. Okay, and the nucleic acid, same thing. Basically, you have to break them apart. So the DNA and RNA have to go to their monomers, and then eventually, what do we break them down into? Nitrogenous bases, sugars, and phosphate ions, all of which we use. Okay, vitamins the same way. We can fat-soluble vitamins because they're fat. You should always remember, typically these are like licensure test questions down the road. The fat-soluble vitamins are A, D, E, and K. Any way you want to remember it. ADEC, CADE, whatever you want to remember. It works like that. In the old days, we thought fat-soluble vitamins were a problem because you could get too many or not enough. Where water-soluble vitamins, you could as many as you want because they're water-soluble, you urinate them out. We found out that that's not the truth. There are some, you can overdose on B vitamins too. So people in the nutrition, and I'm not trying to teach a nutrition course because they know better than I do. Okay. So B12, because it has that intrinsic factor, you might remember from the stomach, gets absorbed there. And so there's some additional K and B vitamins, but basically it's small intestine, maybe a little large intestine. Electrolytes, mostly small intestine, again, maybe a little bit in the large intestine that are there. Iron's kind of special, okay? We have to have transport. Free iron is a problem, so it has to be transported in the blood with a protein that are there. And water, as you can see, 9 liters of water, we absorb 95% of it. Okay, so we try to conserve. There's really just enough water so feces can pass, if you want to think this way. And so anything that messes this up, we kind of classify as malabsorption syndromes, whether it's disease oriented, whether it's medication oriented, whether it's dietarily oriented, anything like that messes you up. It's, to a certain extent, we are what we eat. So, I mean, you do have to be somewhat cautious, would be the right way. You could say it jokingly, but you have to know what certain things are. And we all know somebody who's gluten intolerant or has what they call celiac disease. It's immunological. Glutens are there's almost not a grain in the world. There's only a limited number. So if you're making typical bread with AP flour or bread flour or whole wheat, you pick one, okay? Anything along those lines, you're going to end up with the glutens develop as the bread, as the dough is kneaded. The more you knead it, the more gluten. Bread flour has more protein proportionally than, say, AP or all-purpose flour. And so immunological damage, and the only treatment is really to eliminate it. And Go now to any place. Like now, if you go to a pizza place, okay, you'll pay extra, but they'll have gluten free. They'll have cauliflower for keto, and we've made those types of things. They're not as good as regular pizza. I'm sorry. So you have to eliminate, and that's basically everything. Aren't you happy? I know that you'll find that a little difficult to digest. Haha. It's the last effing day, and for 2 weeks, and you're not a blessed smile. Thanks a lot. With friends like you. Take my students, please. Old joke. So much for that. Now you're stuck. We'll get the urinary tract started. With plenty of time to finish everything, I'm sure. Okay. So that's next on the list for your viewing. I do not have an outline for that. So I don't apologize. It's just I never got around to doing it. And that's the urinary system. And I will summarize it. It does a lot of things. Number one job for when we're urinating or voiding or whatever you want to call it, whatever colloquial term you want to use, is nitrogenous waste removal. When they talked about proteins in the previous chapter, we break them down to amino acids. If you did not know it, okay, I get to write on the board. You tell me you didn't. Who'd you have for AP1? Who taught you guys AP1? Because you're out of sequence.
Oh, Lydia or Jane.
Okay, so Lydia did. Okay, so I'm sure at some juncture she wrote this, right? For an amino acid, right? Remember that?
Okay. She was very hard to understand.
Nobody's perfect.
I know. I was just saying.
I got her the job here. I ran into her at
Yeah,
CCH in North.
smart.
She's brilliant.
But we also had her for like 4 hours.
Yeah, we only had her on Monday nights.
We were all sitting
Yeah,
there like,
we were all dead.
yeah. And it was at like, what, 6 to 8:30?
Yeah, I've seen that movie. I know. Yeah, I ran into her up in that photocopy room at CCH in North, in Perry Highway in North Hills. And I'm like, hey, we're looking for people for A&P. Interesting. She's like, yeah. Okay. So I put her in touch with Dr. Dress, who's our department chair at the time. Voila, here she is. We kind of followed each other. We both showed out in Westmoreland and New Kensington, things like that. Call it the nomadic life of an adjunct. I adjuncted for a number of years, but I've been full-time here for the better part of 15 years. Nevertheless, that's an amino acid. What we do, this is the amino, NH2, ammonia. When you lop those off, this NH2, it quickly becomes NH3, which you and I call ammonia. And we're all familiar with ammonia. I mean, you let a diaper sit before you throw it out, you get that, oh boy, smell. Okay, well, when you're babysitting, we have little ones, and that's because it's becoming ammonia. Ammonia is very toxic inside of you. So we have to find a way to get rid of some of this. So the best way to do it is to take our old friend carbon dioxide, okay, and we kind of change it around. We take 2 of those NH2 groups chemically. You certainly don't have to know this. And we make this magical compound. We kind of lock one of those off, and we put an NH2 here and an NH2 here. And that, everybody, is called urea. And urea is much more soluble in water than ammonia, and about 100 times less toxic. And the name urine comes from urea. So that's what your body does. It has a magical way of taking stuff that's around water, carbon dioxide, that carbonic acid buffer thing. Well, we have all those goodies around. Why not use them to help us? So the kidney, so that happens mostly in the liver. And then when the urea gets to the kidney can get rid of it. We do not have a lot of tolerance for it. The other chemical comes from, you remember a little bit about DNA and RNA? All those bases, the A's, the T's, the G's, and the C's. Good. Okay? A's, T's, and the A's and the G's, adenine, again, you don't have to know, we're not going to reteach it, and guanine are what are known as purines. When the body breaks those down to recycle cells, and the DNA and the RNA, and it's in both DNA and RNA, so we have a lot of it around. Some of it is gotten rid of as waste products. This is the key, URI. It becomes a chemical called uric acid. You learned maybe, because I talked about it a little bit, but you learn about it with joints, something called gout. So uric acid is a disease which is potentially fatal, though we have a lot of good ways to treat it today, is another thing that the kidneys get rid of. And you remember muscles. Remember talking about something called creatinine phosphate in muscles as an energy source? Okay. So muscles, we have energy in muscles, then we have aerobic and anaerobic. Well, creatine phosphate is something like that. So we get rid of it in something called creatinine. Those are, so when we're wondering about those nitrogenous containing proteins and related compounds, that's what we look for when we wonder if somebody's kidney is in trouble. We monitor two chemical tests. One is called BUN, blood urea nitrogen, and the other is called creatinine. And if those start to go up, it tends to suggest a kidney. If it gets too high, then the kidney shut down. That happened to me 17 years ago. And then I ended up in intensive care. So I'm here to tell the tale. Children. I could have been, you could have had somebody else not able to make you guys smile or laugh rather than me. Hopefully you can understand me better than Lydia. Maybe not. I try to be able to speak the English language. And for all my years here in Pittsburgh, I have developed the ability to speak Yinzer. Yinzer? Reading up, gum bands, all that. Oh my Lord, pop. It's a whole different language. It's not the equivalent of Brooklynese or New Yorkese, but I can speak that to some extent. Philadelphia, where I was for 6 years, has yet another language all of its own. So you went from yous guys to Ewans to Yinzers. Philadelphia is you, down in the South, collectively, you collectively, or say y'all. Love that. Here we go. So kidneys, major excretory organ. So it's not just this. It's not just excreting metabolic waste, toxins, and drugs, though I think that's really the critical part. It plays a significant role in overall water volume. So it regulates the amount of water, ion concentration, so your electrolytes are in balance, and if they're not in balance, you're in big trouble. Okay, long-term acid-base balance, that's pH. And hormonally, or as an endocrine, it is able, and these are incorrectly placed. Erythropoietin, which is a typo, regulates RBC production. That's when your red count goes low. Your kidneys sense that from the blood passing through the kidneys and sends a signal to the bone marrow to make more red blood cells. And on the flip side of that is renin, which is released according to fluctuations in blood pressure. If in the kidney, and we'll look at the apparatus that does that, senses a decline in blood pressure, then renin, little granules of renin are released, dissolve in the bloodstream, and trigger a chain reaction to increase your blood pressure. And we'll go into that. It's called and we talked about it ever so slightly earlier. It's called the renin angiotensin aldosterone mechanism. And it's extraordinarily important because we visited it in blood pressure, we visited in endocrine, and now we're visiting it again in kidney. There's a lot to it. So you need to be at least familiar to some extent with that. Vitamin D. Vitamin D is activated by sunlight. When we ingest it, vitamin D, we have to have that to get calcium from our diet. once we get that, for that vitamin D to work, however we ingest it to activate it so it can play a role in bringing in calcium, it has to circulate to the skin where light activates it, and into the kidneys where the kidneys activate it as well. So that's an important role. Okay. It's been my experience, and if I didn't tell you to before, I'll tell it to you now. Most of us, our vitamin D levels are typically lower than they should be. It's a fat soluble vitamin. I think unless you have blood clotting problems, it's probably a good idea to increase your vitamin D till it's a little above levels. That has shown to be a good association with slightly elevated vitamin D and not getting things like breast cancer and prostate cancer. And also plays a role in osteoporosis. And given that there's no guys here today, all of you are candidates for osteoporosis. So be very aware of it, please. It's such a bad pig. I know, and I don't want to show it. You can see what my first wife, who was very diminutive to start with, really, she's just not doing as great as. And she's just slightly older than I am. But very diminutive, osteoporosis, problems with prematurely menopausal. I'll tell you more about that stuff. It's been a very difficult road for her, fortunately. So the kidneys are really the organ that does the work. In the old days, we used to call it upper and lower anatomically. The kidneys were the upper urinary tract and everything else was lower. Now we just talk about the kidneys. That's really all the functionality, the major anatomy. The urinary tract really has nothing to do with processing. It is merely the ureters which carry the urine from already processed urine, good to go or good to go out if you want to think of it that way, by way of ureters, two tubes that insert into the bladder, which is a temporary holding tank, and it exits by way of the urethra. That's it. So it's more about what can go wrong there. It really doesn't do any processing per se. So we get that's in the next PowerPoint of this sequence. Unfortunately, you'll be stuck having to learn about it because that's the bladder's where my cancer is. So anytime you have something like that, interesting topic, a pet peeve, or a problem where somebody's research, you're going to get a lot of questions in school about it. Just saying. Voila. Your basic kidneys. Noteworthy. The right one, because the liver is so big, it pushes it down a little bit lower. They're really approximately the same size. Okay. They're the typical quote unquote kidney shape, convex, laterally, concave, medially. The medial area is called the hilum. That's the entry and exit points for blood vessels, nerves, lymphatics, urine, for instance. So effectively, this is where the urine exits by way of the ureters, inserts into the bladder, kind of underneath, and the urethra kind of comes out also underneath. There are all those structures, the kidney, the ureters, the bladder, the urethra, are all effectively retroperitoneal. So they're not moving around at all. They're kind of fixed points. The first and most notable thing, again, and I pointed it out before when we did blood vessels, is here's the adrenal artery. Generally, arteries, as you get farther away from the heart, get smaller. So the adrenal arteries, or suprarenal arteries as they're known, and the renal arteries are immensely bigger. Okay? Disproportionately so. That's because the kidneys are a high pressure filter. Effectively, that's what they do. They filter the blood, I don't know. You'll see the numbers that are there. A ridiculous amount of times, like 30 times a day, just ballpark. All the blood going through the kidneys. The only way the filter works is with high pressure. If you don't have enough pressure, for whatever reason, that's why if people go into shock, you're worried their kidneys are going to shut down. The kidney has one response to any adversity. It shuts down. If it's clogged, it shuts down. If there's not enough pressure, it shuts down. If there's an infection, it shuts down. Anything along those lines, it shuts down. That's what happened to me. My kidneys shut down because of an infection. And effectively, I developed shock from the infection. And that was the cause of it. So they're very sensitive. So in order for the kidneys to do their thing, they need pressure. It relies on pressure to create filtration. It's like if you have a drip coffee maker and you put the water in there and you put the filter in there and you put the coffee in there and you forget to turn it on, you can come back 10 hours from now, there's not going to be any coffee until it's the water. And if there's something blocking the water dripping, it's not going to have anything. But once the water starts to come through, it's going to work. Kidneys are like that. And it's a decent enough analogy because if there's too much pressure, you take a typical coffee filter and turn your sink on high in the kitchen and put the filter under, what's going to happen? Tear right through it. So not enough pressure doesn't work. Too much pressure tears. Analogous to the kidney. Just saying. So now you can kind of see the lay of the land. That's more or less with this. And there it is in situ. That gross and that was pretty gross, the picture. I heard you're off for the holiday. What are you going to do next term when you're busy? I don't know. It's okay. You guys play late, hopefully. Yeah, real late. I told you, I watched that last game.
Yeah.
Not a lot of us did, but I went out looking for it. So they're retroperitoneal, and you're going to see now they're kind of protected by the rib cage. Important things have a certain amount of bony cover that are there. So you can see they're roughly in the lumbar region. Right kidney's a little bit lower. The adrenal glands sit on top, concave and convex. That's the hilum, etc. Here they are. You can see there's the way the ribs kind of angle downward. Not all of it, but a lot of it are protected by that. That's when somebody's struck in that area, auto accident, a fight, that type of thing. You look for like blood in the urine because that's a sign that potentially there might have been some damage to the kidney. So it's very interesting. We look for getting blood, and we are looking not so much for microscopic changes. You're looking for actual red in the urine, as opposed to somebody with a urinary tract infection, much more common in women than in men. You'll get discoloration of the urine. And it'll be basically maybe a tiny amount of microscopic blood in there that will discolor it slightly, as opposed to red, which suggests that there's something significant going on more than that down the road. So it has rather substantial anchoring tissue that's dense, we call fascia. It has a certain amount of fat around it, just like the heart. Important structures have a certain degree of protection that's afforded to them. So that's another example of that. And it has a rather thick capsule. It's funny, we have some kidneys up in the lab, sheep kidneys to dissect, and my lab Monday dissected them. And unfortunately, you couldn't really see what I'm going to show you very soon about maybe it's just a sheep. And so I think if we do that mammalian dissection, what I order, I don't know if we have them still, is what is called doubly injected. When you do I wouldn't do a cat. We have cats. I can't bear dissecting. I couldn't look cloud or tucks in the eye or cats. Do you want to dissect a cat? I don't think so. No. I could go home and go, I'm sorry, I saw your Uncle Ralph. He's not doing very well. He's kind of cut up. I can't do that. You can't have the cat crawl on your lap when you just dissected it's a great uncle. Be wrong. No, I have no allegiance to the fetal pig. But we doubly inject them, which means they inject dye into the arteries and the veins so you can get outlines. So hopefully they have this. Maybe not. No guarantees. So you can see this is what's meant by retroperitoneal. All the organs are in here. This is all back here. So you would have to be a massive. This is the kind of thing that kind of happened back in the day before we wore 3-point seat belts. We just had either lap belts or you didn't have the part that comes over the top. is that people would come forward and you could lacerate one of these red vessels that were there, and they would die from that. So I mean, the seatbelts have been important, though people were very resistant. I came from when we started driving, we didn't have seatbelts at all. Okay, so the thoracic, perirenal fat, lower parts more susceptible because the right's lower, and this is where we get all that thing. Sports injuries are part of it that are there. The artery, and this is the rapid deceleration that they talked about, and that's why a lot of problems, and that's the sign, hematuria. When we see red, it's called gross hematuria. When you see discoloration, you just call it discoloration, and you dipstick it or do additional testing to find out. So you're going to see, just like any other organ, the kidney, the exterior is called the cortex, like your bone. Cortical bone on the outside, medullary bone on the inside. Same thing with the kidney. The interesting part, the filtration all happens in the cortex. The formation of the urine and the concentration of the urine very much is in the medulla. And so it's very, very distinct anatomically and relatively easy to understand. And the best way to understand it, it's a series of funnels. Very much so, more than anything else. It's very much a series of funnels where the urine is produced, where first what's called filtrate is produced. That's the liquid that comes out of the blood, but there's not blood supposed to be in there or proteins. And then that's carried along through a series of tubules. And eventually, as the urine is processed, it goes into another funnel that drains into yet another funnel and another funnel, and voila, we have urine. So you're going to see under the cortex, the outer layer, you're going to see these conical with the points sort of pointing toward the hilum medially and the base pointing outside or toward the cortex laterally of what appear to be pyramids. And that's what we couldn't see on that sheep dissection. It just wasn't clear. You could kind of make it out if you used your finger in the glove and sort of felt along, because it's a different texture type of component, but it's a series of what appear to be ribbed structures, which are a series of tubules and membranes and blood vessels that are in the process of normally concentrating the urine. So the pyramid, the base outside, the tip, they call it the papilla. Okay, there's tissue in between them. That's the passageway for blood vessels. I'll show you in a second. And each one of these areas with a pyramid and the cortex on top, they call it a lobe. And typically there's 8. So I'll come back and show you this thing in a second. Let me go back and go back to it. So here it is. That's what a human kidney would look like dissected. And so this is what we couldn't see in the sheep because it's so small. We started to see some color changes and some texture changes. These are pyramids. So 1, 2, 3, 4, 5, 6, 7, 8, which is about right. I mean, I'm sure there's variation. And these are sort of like the funnel areas that form and collect. So it's better seen here on the actual illustration. So the cortex appears very granular and it's on the outside. The columns, here's the pyramid, base to the outside, tip or papilla, pointing toward the middle, so to speak. And the tissue in between is the passageway for arteries and veins. Basically, the blood throws in, splits, goes up here, goes up here, goes up here, etc., kind of curls over or arches over, and then we'll see a series of about 1 million specialized capillary beds that start the process of making the urine eventually. I didn't turn off my ringer. So sorry. So we'll take a look at that. And so when we look at it, you're going to see that what they all drain to is this sort of common opening a la funnel. That's called the renal pelvis. And the stem of that funnel is the start of the urine. That renal pelvis is formed by what are called major calyces. Calyx is the singular. I love, you know me, I like singulars and plurals. Love that. Octopus, octopi, alumni, deer. sheep, fish. It's language. Should I show you that picture we got from a mug we were trying to sell on eBay? Go big or go gnome. Should be everybody's selling it. Not a great deal. Moving on. And so these are called major. So this collecting area here that you can see, this is the pelvis, where the confluence here are called major calyces or major calyx. And there at the tip of each papilla is called a minor calyx. So you'll see, so this is what they're referring to here. The funnel-shaped tube that becomes the ureter, renal pelvis. Minor calyces, cups, the opening for the funnel at the tip of each pyramid. Confluencing 2 or 3 of those is a major calyx. And then the pelvis basically is all of the 3 major calyces, usually there's 3, empty into the renal pelvis. So you should know the flow. So it goes basically from the tip of the pyramids, minor, major, pelvis, ureter. So that's a typical anatomical question. We do a lot of that stuff. So, and when it's infected, it can be if it's the pelvis and the calyces, pyelitis, but this is the one that you with infections. And effectively, since it's a series of funnels, ultimately, you hear me say this a lot with GI, ultimately, and you see it with repro the same way, it's a plumbing problem. When there's a blockage, okay, or there's damage, things, if they can't go out, go up. And that's the big problem with urinary tract infections if they're not treated. And it's more of a problem in the female than in the male just because of the length of the urethra. It tends to ascend. Okay. And when it ascends, understand this. When we take a look at the kidney, these tubular structures that do all the processing of the urine are surrounded by blood vessels. Just like, remember the lung. And all those chambers for the air, and each one of them is surrounded by blood vessels. When there's damage to the lung, like pneumonia, and it ruptures one of those chambers, immediately that infection gets into the blood vessels and travel. Tuberculosis does that. In the kidney, same thing. If there's an infection in the kidney, it will cause damage in that interface between the tubule-like structures and the blood vessels that surround them, and it can immediately travel. Our rule I learned this, almost 50 years ago. When you do a pre-op study for a patient you're going to operate on, and they have evidence of bacteria in the urine or something unusual in the urine, typically you cancel the surgery. If it's an elective, and mostly we did elective surgeries. Because you're like asking for a post-op infection. That's the relationship. It's why we do those the preoperative tests, why they do blood counts and chemistries and urinalysis. It's a quick snapshot of overall health, and you can determine, hey, is this a red flag? It's not like, something you have to operate on if it's elective that you couldn't do next week or in 2 weeks or a month. So a lot of problems associated with it. And unfortunately, antibiotics work, but you have to use stronger antibiotics than the ones we typically use for urinary tract infections. They're there. It's an extraordinarily good blood supply because it's under such pressure and power. About sitting here, you and I, at rest, about a quarter of our blood, quarter of what we call cardiac output, is going to your kidneys each minute. And you'll see the flow from the renal arteries up through those lobes, and it arches over them, and you're going to see what happens afterwards. The nerve supply is strictly sympathetic, where parasympathetic governs your gut for the most part, holds your heart from being excessively rapid for the most part. What it does has nothing to do with the kidney, because the kidney is all about blood flow, and sympathetic nerves are all about blood flow. Voila. This is what you see. So when we look at it as they branch, they go up those columns, And then what happens, the vessels arch. We call them arcuate arteries and arcuate veins. It means they arch over the base of the pyramid. And then we see vessels radiate into the cortex. And off of each of those radiating vessels, like little nubs, is a tuft of capillaries that are very unique. And they form something called the glomerulus. Okay. And they're the leading into something called the nephron, which is the critical piece. That's how kidneys work. It's surely the most important functional piece in the kidney. And this may be the hardest part to understand, but it shouldn't be. Normally, when blood gets smaller and smaller vessels, and it gets to an arterial, you remember this from blood vessels, they open up into a capillary bed. So in a capillary bed, that's where the oxygen goes out, the carbon dioxide comes in, nutrients go out, waste products come in. And at the end of the capillary bed, we have venous blood. It gave up its oxygen, or a portion of its oxygen. Not here. This is the only place in the human body where an arterial enters a capillary bed. So it breaks all the way down from the cortical arteries to the arching arteries, cortical radiating arteries, and forms tiny vessels called afferent, or incoming arterioles. They enter a unique capillary bed called the glomerulus. And when they exit by way of the efferent, or outgoing arteriole, it's still arterial blood. Why? It exits because pressure. Normally, to get something through a capillary bed, you're going to have to release energy. Capillary beds are where, again, oxygen and carbon dioxide exchange, nutrients and waste products. Not here. What happens in the glomerulus is filtration, and filtration relies on pressure as the driving force, so it doesn't have to expend its own supply of oxygen for energy. Hence, arterial blood enters and arterial blood exits. Once it leaves the glomerulus by way of this efferent arteriole, it's going to go into one of two different types of what are called nephrons that you will see, and then that's where the processing. That's how we reclaim the stuff we want, we get rid of the stuff we don't want, we finalize the concentration, and then it enters one of two sets of veins called the peritubular capillaries or vasa recta, and then finally, as it exits those, now it's regular venous blood, and it's going to go out to the inferior vena cava eventually. So it's the only place, and not just for my tests, for tests, anytime you have something that's unique, out of the ordinary, something different than anything else, one of these things is not like the others, one of these things is not the same. Sesame Street. I know. I'm still mad they took away the Cookie Monster. C is for cookie, it's good enough for me. Look, I've been through this at my age. Sesame Street came out when we were in high school, more or less. We used to watch it because they have all these Hollywood people would get on there and do the alphabet for the kids. And then by the next step, my kids, then my older granddaughter, now my younger. It's just like 4 levels of Sesame Street. You know Mr. Rogers' story? Cookies are bad for you. Now he's a veggie monster. Yes.
No, there's no. That's the Cookie Monster.
What? I know there's still a cookie monster, but a lot of times they have a veggie monster.
Cookies are good every once in a while.
No, they're good all the time. It, 2 weeks ago Thursday, when my son came up, did I tell you we met at a restaurant in Oakmont, okay, called The Loft? I know where that is. No, I guess not. Okay, it's where they're building a residential area with like townhouses and on the water over there. Very nice. Entirely too expensive. Thankfully, I was not paying. And Joe tried to leave the tip. And it took all, my wife and I took all of our strength, our power, not to stop at the Oakmont Bakery. If you haven't stopped at the Oakmont Bakery, go. Spend the day. If it's on Saturday or Sunday, it's going to take an hour to get served. It's going to take a half an hour to park. Oakmont Bakery. What would you know about a bakery? I mean, there's no reason my daughter can eat at those places. She works out for an hour and a half every morning. She's one of those. Oh, Dad, I'm running the marathon. You're nuts. It's only a half marathon. You're half nuts. My eldest has run 6 marathons. So you didn't watch Sesame Street as children? Oh, thank goodness. How about Mr. Rogers? Pittsburgh institution. I gotta digress. Did I tell you the Mr. Rogers story? Oh, come on. The late Fred Rogers lived around, obviously around here in Pittsburgh for a very long time. I think he might have lived, it was, I'm sure, sort of east of the Squirrel Hill area, like off the Parkway East in that neck of the woods, as I recall. And what he did was every Sunday, we didn't know this, but he swam every day to stay in shape. He was always very, very trim and healthy. He swam, where he swam, interestingly enough, for someone who is an ordained minister from Pittsburgh Theological Seminary, down in, if you're familiar at all with the East End, right down in that area. And it's sort of like they're trying to gentrify that area. It's a very interesting area that was there. When I first came to Pittsburgh back in 1977, very interesting. So he swam in Squirrel Hill at the confluence of Murray and Forbes Avenue, which is where the Jewish Community Center is. So they have a big, the center has a big health club and swimming pool. And my kids who were little, this would have been 1990, 1991. Okay. And so my boy, and on Sundays is when, because Saturdays there wasn't a lot of activity because of the Sabbath. So Sundays were a big day for kids to swim. So our kids, that was the weekend day you put your kids for swimming lessons. So my daughter was too young. She was going to preschool there. My oldest was doing, both my boys were doing swimming lessons at what we call the Jewish Y. And they have like the kids pool where they were doing the lessons because they were like 7 and 6. And you could see the rest of the pool, people swimming, and there was a lap pool. People were swimming back and forth. So I got my boys into the locker room and got them all changed. And I said, look, give me a holler. As soon as you come out, I'll help you get dressed and we'll go home or we'll go out to get something to eat. They said, oh, we're big boys. We can get changed ourselves. Okay. And all the moms and dads are sitting out there just outside the door, the men's and women's locker room. And we're watching, and then it goes on, not paying any attention. All of a sudden, my Navy captain of all of age 7 runs out going, Dad, Mr. Rogers, he's in the locker room, naked. 100% true story. And thankfully, and we're just like, oh my gosh. And almost immediately after, fortunately, my kid had his clothes on. Out come my other son with his clothes on. Out comes Mr. Rogers, thankfully not naked, with his clothes on. And he started talking to all the parents, signing everything. That's honest to goodness. And then I found out from one of the other parents who were there, go, yeah, he swims here every day, and he's always here on Sundays doing laps. So we all got to meet Mr. Rogers. See, Pittsburgh institution. I can still to this day tell that story, as I've done to you now. I even told it on the ship where he's the captain. Here he comes out. He's in there, naked. All right. So our next visit will be with the nephron. This is the major unit, both structure and functional, in the human kidney. I'll probably do some of this stuff for you to continue this online. If you have the tests, pass them in to me. It's really important stuff because you really how the kidney works. All right. And so everybody if I don't see you, so for anybody who didn't hear, I'll do the lab virtually. I'll try to get a head start on these things. All right. And we'll see you then.
If not, we'll email you.
What?
If our tests, if we don't get them back, we'll email you.
Yeah, email me about the test. Email me about the study guide. Hey, I don't have my computer. I have a built-in excuse. I have a computer at home that can't do all the same stuff as our computer. I try to load stuff on YouTube because you don't have enough room. You can't do this.
Do you want them just here?
Yeah, just pile them up. But have a happy turkey, all that good stuff.